Concurrency is what makes Golang an extremely powerful language. But a large majority of people are completely confused when it comes to concurrency. So in this video, I'll be explaining to you what is concurrency in 5 minutes like you're a 5-year-old. Concurrency in the context of Golang has 3 important pillars: goroutines, channels, and wait groups. But wait, before we get drawn deeply into concurrency, we must first answer the age-old question: is concurrency and parallelism the same thing, or are they two different things? If they're different, what are the differences? To answer this question, let's first look at a very vanilla sequentially processing program. So let's assume that this is our timeline. Time starts from 0, goes all the way. And there are 2 tasks, task 1 and task 2. In a sequential program, the task 2 cannot be started until task 1 has started and completed, right? So task 2 will never get done out here or out here or out here. It will always be done after task 1 has started and completed. Until that time, entire process keeps waiting for task 1 to complete. In parallelism, task 1 and task 2 can both be worked upon at the same time, and task 2 can even be finished before task 1. In concurrency, the program can juggle between task 1 and task 2 with respect to time, depending on which task requires more processing resources. Routines, which are the first building block of concurrency in Golang, are simply a way to start off multiple concurrent processes. The way to start off a process is by using the Go keyword. So let's assume that our Go compiler is compiling this program, which has 3 Go function calls. When it encounters the first Go function call, it starts off a new process as a goroutine. A split microsecond later, it encounters the second Go function call and starts off another process, which is process 2, as another goroutine. And after a split microsecond later, it encounters the third Go function call, starts off process 3. Now it starts juggling between these processes and these tasks. So imagine that these tasks are basically calling an API and getting some response. Now Golang becomes aware and intelligent, and it understands that process 1 is now waiting for some data to come back from an API. And by that time, while the waiting is going on, it starts using those computing resources to work with process 2. And similarly, when process 2 is waiting for some data to come back from an API, it starts using those computing resources for process 3. Again, the same thing happens, process 1, process 2, process 3. It keeps juggling between these tasks with time. As you can see on the left, time is increasing. And then when it checks that process 3 is complete, it then understands that it can now use the same computing resources between process 1 and process 2. And with time, process 1 is also now complete. And now it can use all of the computing resources for process 2. So process 2 took very long to complete, and at the end, the process 2 is also now complete. Now imagine if this was a sequential program, we would have had to wait for process 1 and 2 to complete before even beginning process 3, which is not fair because process 2 is extremely long. But here we were able to complete process 3 and return the value way before process 2 completed. Let's talk about channels. Now let's imagine that there are 2 tasks. Task 1 is responsible for calling an API that returns a list of 100 URLs, and it's handed over as data to task 2, which basically calls every single of those URLs that have been returned by task 1. Now, if we were using sequential processing, we would have had to wait for task 1 to finish processing before task 2 could start calling all those 100 URLs. But with Golang and with concurrency, there's a much better way. Now, we can make some changes to our program to make both the tasks run concurrently. Task 1 will be responsible for fetching only 10 URLs at a time, and task 2 will be responsible for calling only those 10 URLs at that particular time. That means both of these need to communicate with each other regarding those 10 URLs. And this is where channels come in. Goroutine 1 is responsible for process 1 on the left. Goroutine 2 is responsible for process 2 on the right. And Golang can juggle between the 2 processes depending on which process requires more computing resources. Goroutine 1 can call an API and get a list of 10 URLs, and Goroutine 2 can call all those 10 URLs. They can use channels to stay in sync. That means every single time, Goroutine 1 can publish 10 URLs to the channel. Goroutine 2 can take those 10 URLs and start making those API calls. And this is how channels can be used between goroutines to stay in sync. This is a very common concurrency pattern in Golang, especially used when building crawlers. On this YouTube channel, we've built multiple types of crawlers and we've used this pattern very often. The way it works in a crawler is that the first goroutine visits the sitemap and outputs a list of the URLs that need to be visited onto a channel. And Goroutine 2 can pick up those URL lists from the channel and start calling all those links and start scraping the information. And that's how you can scrape a website more efficiently. To understand wait groups, we first need to understand what concurrency without using any wait groups is like. This is our main program, which also is our main process. It spawns off a goroutine, which is process 1. and it also spawns off another goroutine, which is process 2. But it ends up finishing execution way before process 1 and 2. Now, assuming that it had to print out the responses from process 1 and 2, it won't be able to do that in this scenario because it ends up executing way before process 1 and process 2. It won't get any reasonable response back, so it will be only able to print out garbage values. This is a concurrency scenario with using wait groups. We have our main process. It spawns off two processes, process 1 and process 2, as two separate coroutines. But when it was creating these processes, it also added both of these processes to something called as a wait group. So when we see wg.add2, it basically means that it adds these two processes to the wait group. When the main process wants to end here, just like last time, it now needs to check with the wait group, hey, can I stop because I can't wait anymore. This time the wait group responds saying that, hey, you can't stop right now, you can't pass because you have to wait for both of these processes to end. Main process cannot end till both of these other two processes and goroutines have resolved. So at this point only the main process can end, and this means that if main was expecting some response from process 1 and process 2, wanted to print this, then in this scenario it will be perfectly possible.